All right, let's try this again. Apparently, we've had a storm roll through and I lost internet connection, so this last bit of the video got cut off. So I'm going to start this problem all over again. This is the last problem I'm going to do for rational expressions. So if you missed it, or you watch the video to the end, you're like, oh, what happened? Here's the rest of this problem. So I'm going to start from the beginning. Again, we need to find, because we are adding and subtracting, we need to find a common denominator. But before I can find a common denominator, I need to go through and factor everything. So if I go through and factor this, x squared minus 1 is going to factor out to be x plus 1, x minus 1. X squared plus x is going to factor out to be x times x plus 1. And then x squared minus x is going to factor out to be x times x minus 1. Now, the LCD needs to include all my different factors that I show. So I need to have an x plus 1, an x minus 1, and an x. So even though I have more of those in this problem, I only need one. One's going to help, or one of each one's going to fix everything. It's going to count for everything. So let me make a note here what my LCD is. So that's all the different factors that I show. So I need to take and make sure that that's on the bottom of all of my fractions. So I'm going to go through and multiply every single fraction by what I'm missing. So with this first fraction, I have an x plus 1, x minus 1. I'm missing the x. I'm going to multiply the top and the bottom by x. The reason we have to do it to the top and the bottom is because you don't want to change the value of your fraction, just the appearance. X over x is equivalent to 1. You're getting the same fraction that you started with, it just looks different. On this second fraction, I've got an x plus 1. I need the x minus 1. We got an x minus 1 on top and bottom. And on the last fraction, I'm missing x plus 1. Now, we can agree that all three of our fractions have the same things on the bottom or in the denominator. Because that's the case, I am going to write the common denominator on the bottom. I'm going to run out of room very quickly. So this is my way of keeping from running out of room. Let's write what we've got left on top. I have an x times 5x plus 2. Okay, I've got a 3 times x minus 1 and negative 1 times x plus 1. We are now going to go through and clean this up. I'm going to distribute out my x. I'm going to distribute out my positive 3. And I'm going to distribute out my negative 1. If I multiply, I've got 5x squared plus 2x plus 3x minus 3 minus x minus 1 all over that common denominator. We're not going to clean this thing up until the very end of the problem. So you're not going to see me cancel anything out until the very end. This is different than multiplication or division. Canceling stuff out is actually one of my first steps. With addition and subtraction, it's actually our last. I think I said, did I say multiplication and division? I hope so. Multiplication and division, you cancel out early. Addition and subtraction, you cancel out at the very end. Let's combine like terms. I'm going to have a 5x squared. And then 2x plus 3x is 5x minus x is a 4x. So positive 4x. And negative 3 minus 1 is negative 4. All over x times x plus 1, x minus 1. Now, if I wanted to reduce this, if it's possible, I'm going to have to factor. So remember, you cannot cancel bits and pieces of trinomials and binomials and all that. It has to be all or nothing. If I go through and try to factor the top of this, I'm looking for factors of -20 that are going to add to be 4. It's a trinomial, so I'm going to use the AC method, or the factoring by grouping. Factors of -20 that add to be 4. I've got 1 times 20, 2 times 10, 4 times 5. Looking at this list, there is no way any of these factors are going to add to be 4. 1 and 20 is not going to do it. 2 and 10 is not going to do it. And 4 and 5, the closest I'm going to get is 1 or 9. So none of these are 4. That means to me, this is my final answer. Okay, so that's the end of rational expressions, guys. I apologize for the video. It took a while to get everything back up and running. So if there's a little gap, you can go back and check if it seems like I skipped over anything, go back and check out the other rational expressions video. And we almost got to the end of this problem. There you go.